Hello everyone, my name is David Rodriguez. I am an astronomical data scientist here at the Mikulski Archive for Space Telescopes, that's MAST. It is my pleasure today to talk to you about what we do at MAST and showcase some of the missions we have and some of the data and tools that we've developed. Before jumping too much into this, I do want to point out that we have a booth here at the Space Telescope area, so feel free to stop by at any time if you have questions or want to see demos or want to ask, how to get to your data. So MAST was founded in 1997 as a permanent home for IOE and HST data, and since then it's grown tremendously as we've added additional missions both before that time and during the years since. So right now we have over 40 years of effectively data in our holdings. In the next slide, I'll show you, I'll walk you through some of the main missions that we have in our multi-mission catalog. And we will build up the image that you see on the background, so it'll become a little bit more clear. But I'll be showing you the coverage of these missions in galactic projection, and on the background, I'll have a Gaia density map for two reasons. One, as a frame of reference, so you can see where the galactic plane is and the Magellanic Clouds, and also to highlight that the Gaia data is also stored at MAST, and I'll talk a little bit more about catalogs at MAST towards the end of my talk. So let's get started with this movie, and let's get started with the beginning of it all, the International Ultraviolet Explorer, IUE. Back from 1978, it was expected to run for 3 years and ran for 18. And it covered quite a bit of the sky at ultraviolet wavelengths. You can see, for example, here is the Magellanic Clouds for reference, as I was mentioning earlier. Next up, I have a brief mention for the Shuttle Mission. So there's 4 telescopes here that flew above the space shuttle in the early 90s. They observe about 1,000 stars to get ultraviolet spectroscopy. So even small missions like these are valuable for MAST, and we do hold the data in our archives. EUV, the Extreme Ultraviolet Explorer, is another ultraviolet mission. I'm showing here just the spectroscopic observations, but we do have the all-sky imaging, or the all-sky catalog that was produced here. It's just not in the same database, so I'm not including it in this particular movie. HST we all know and love, right? This is the Hubble Space Telescope. This has been around for, it's going to be 30 years this 2020. The estimate of the volume of data here, 140 terabytes, that is a lower limit in the sense that I'm only counting the science grade files that we have on our multi-mission archive. There is additional data for calibration and references and models and catalogs that are not part of this estimate. So the volumes you're seeing there are lower limits. Fuse is another ultraviolet mission, Far Ultraviolet Spectroscopic Explorer. And I believe next is Galaxy, the Galaxy Evolution Explorer satellite. This is one of my personal favorites, mostly because I did my thesis work with Galaxy data. So I was looking for nearby young stars, and it turns out young stars are chromospherically active, so they show up quite brightly in ultraviolet data. And since this covers quite a large region of the sky, it makes it very easy to discover these types of stars. SWIFT is an interesting observatory. So the SWIFT observatory actually observes the gamma rays, X-rays, and ultraviolet and optical. The majority of the data is at HESARC, but MAST holds a copy of the ultraviolet and optical data. So you're able to find this data as you are exploring our archives as well. Kepler. Kepler is amazing. You may have heard of it. It's excellent. I'm not showing the K2 fields for completeness, but we do have the K2 fields as well. Kepler is probably best known for extrasolar planets, but it's also very well known for astroseismology and transient studies of all kinds. PanSTARRS is a ground-based mission, which is sort of why you see this gap in the coverage, in the sense that this is the southern hemisphere, and PanSTARRS is located on Haleakala in Maui, where you can see a little bit towards the south, but you can't see all the way across the sky. So there is a limited coverage. But this is a huge amount of data. PanSTARRS alone is a petabyte of just imaging data, and about a little bit more of that in terms of catalogs. I'll touch on TESS a little bit more towards the end. But TESS is amazing. We should all be very excited about TESS. I won't say too much here, except just to point out that when I created this figure, this was in November, so we didn't have the full amount of data that we do have today. The last one I want to mention for this slide are HLSPs. This stands for high-level science products. This is when you, the community, produce additional data based on existing products. Say you extract sources from some images, or you do some fancy algorithm to reduce the data in some very special way or calibrate in a special way, and you distribute it through MAST towards the community. And so MAST is all of this. MAST manages to capture all of this information into a single catalog, into a single database that the users can query. And that's one of its strengths, that you can go to our variety of interfaces and our variety of tools and access all of the set of data with a single click and a single a set of functional calls if you're doing Python, or a single clicks if you're doing our web-based portal. You can explore all the way from the ultraviolet to the infrared, especially with missions like ST and WFIRST coming along. And it's also very important to note that a lot of data is science ready. So a lot of this is already processed through our pipelines. All you need to do is download and start working with it. Now you can get the raw data and calibrate it yourself. It's up to you, it depends on your particular case study. So I mentioned earlier catalogs, and I wanted to show an image of the pan-stars density of sources. Before I was showing the Gaia, so I just want to show pan-stars for comparison. And to highlight that we have an interface called catalogs.mast, where you can explore and download sources. You can query the pan-stars catalog in a variety of different ways, code searches and parameter searches, and get results that way. Catalogs.mast also has the Hubble source catalog, the Hubble catalog of variables, and we hope that in the coming years this will be your one-stop shop for all catalog data at MAST. If you study exoplanets, you may have heard of ExoMAST, and if not, you are learning about it now. So ExoMAST is an interface that is specifically geared for the discovery of data related to extrasolar planets. What I'm showing here in orange are confirmed planets from a variety of different catalogs, from NextC, for example, exoplanets.org, the KOI list, for example, and in blue are the test candidates that are coming along with the test mission. All of these sources that you see here are fully explorable in ExoMAST. So you can go query by a particular name and get some quick look tools, see light curves, see the actual data, and explore it in a lot of different ways. And if you're not interested in extrasolar planets, maybe you're interested in high redshift galaxies. So we have a new interface that we're prototyping here, and I encourage you to stop by our booth and get a demo of it. This is Z.MAST, where we're showing it's a way to explore very deep fields that have been observed by HST and Spitzer and a couple of other observatories. The ones in blue are the ones that we currently have, and the ones in orange are things that we will be adding shortly. So look forward to more deep fields being added to this interface. And so MAST is continuing to grow every day, pretty much. TESS every month delivers roughly 3 terabytes of data. What I'm showing here are the various test sectors, basically a month's worth of observations being carried out on a particular area of the sky, and slowly you're seeing various sectors filling up. You will see that it goes all the way to sector 16. Currently, MAST holds up to sector 18. TESS is an incredible mission for time domain astronomy. We've heard in this very AAS press releases about new planet discoveries, tidal disruption events, supernova, asteroids. All of these studies are enhanced by a mission like TESS that covers so much of the sky with this particular cadence. And it's not just TESS, right? Other missions are continuously adding to MAST, right? We have in the future to look forward to JWST and WFIRST, but even currently we have tons of high-level science products being produced by astronomers, and we host them here for the community to explore. And so with that, I will end my presentation with a reminder that we are located just across the corner at the Space Telescope booth. So please stop by. You can get a demo of our various interfaces, and you can ask us questions there. But if you have any short questions right now, I would be happy to take them. Thank you for your time. Questions, comments? You're all stunned by MAST. Yes. So the question was if I could go back to z.mass slide. Let's see if this works. There you go. So the question was, how are we selecting which fields we are gathering for this? We work closely with the astronomers at Space Telescope to decide which HLSP missions we should be adding. So these are particular HLSPs that have delivered to MAST very deep catalogs. And so we go to the astronomers in our institute and we ask them, which ones should we focus on next? Should we focus on ones with imaging, spectroscopy? You know, what exactly do you want to see? And so the ones in blue were the ones that were highlighted as, yeah, we should deal with these first. Right, there are no more questions. Thank you again for your time, and I look forward to talking to you in the MAST booth. So please stop by. Thanks.